Okay, so like I mentioned, the first portion of this address is the domain identifier. So each switch is going to get a unique domain ID. Just like you can do in the IP world, you can manually assign this, but otherwise it's going to be auto-generated. Okay, there's a device called the principal switch. The principal switch, you can think of this loosely analogous to a spanning tree root bridge, and it's chosen based on an automatic election. What's interesting, though, we'll see about these fabric services within the scope of Fibre Channel, you don't need to configure them. They're automatically on as soon as you shut the link. So like in the case of IP, you need to manually configure your DHCP server, give it the DHCP scope, do any manual reservations that you want to. In the case of Fibre Channel, you just say no shut on the port. It's automatically running the domain ID service. It's automatically supplying the end hosts with the FCIDs. It's automatically routing with the other switches running Fabric shortest path first. And the manual configuration we need to do is going to be the access control, the zoning. Okay, but other than that, you'll see most of the stuff is going to be plug and play from a configuration point of view. Okay, so like I mentioned, one of the differences from a data plane forwarding point of view in Fibre Channel versus Ethernet is that Fibre Channel does not use flood and learn. Okay, in the case of Ethernet, I have a packet come in my Ethernet interface towards the host. I look at the destination MAC address. If I don't know the destination MAC, I flood the packet everywhere. Okay, this is how we discover where the end hosts are located in Ethernet. But in the case of Fibre Channel, we're routing. Okay, so we form an active routing adjacency. We form an FSPF adjacency. We run the Dijkstra shortest path first algorithm, just like OSPF or IS to IS would. And the node identifier we're using is the domain ID. So the router ID effectively is the first byte of your domain identifier. Excuse me, first byte of your Fibre Channel identifier. Okay, so first byte is called the domain ID. So we route the traffic to the switch, we route it to the domain ID, and then that switch is going to know what the directly connected hosts are. So we'll see that from a routing point of view, the topology is normally very, very simple. You typically only have two levels of hierarchy in your storage network. You have the core switch that's actually attached to the array, and then you have the edge switches that are attached to the initiators, okay, like the top of rack. So depending on how many switches you have, that's going to be how many nodes you would have in the FSPF, Fabric shortest path first database. And then that would determine how long it takes the network to reconverge if you have a link flap. But it works just like OSPF. Link goes down, link comes up. You generate a link state advertisement about it. You need to rerun shortest path first. You throw the old tree away. You install the new tree. Then you begin to forward traffic. Okay, the reason that we have two SAN fabrics, A fabric versus B fabric, is because of FSPF. Okay, the reason why is that just like OSPF, just like ISIS, I make my routing decision and I'm deciding that I'm going to switch 1, 2, 3, 4 in order to get to destination X. Okay, switch number 3 goes down. I have to wait some time to detect that. So there's going to be a convergence delay to figure out that there was a failure. There's going to be a convergence delay when I flood the changes, tell everybody else that, hey, there was a change in the topology. There's going to be a convergence delay while I'm calculating the new topology, so actually running SPF on the CPU, and then there's going to be another convergence delay while I'm installing the updates into hardware. So those 4 pieces of convergence, just like they exist in the IP world, exist in Fibre Channel, and the issue is that while I'm in the middle of convergence, traffic is being dropped. So if I'm reading to the database or writing to the database and one of the links goes down, FSPF goes to reconverge, the issue is that my frames are dropped. But the problem is that the upper layers in Fibre Channel can't deal with that. So the CPU is not going to do a retransmission if you can't hit the database, okay, because it thinks that the disk is physically attached. So what we do instead is we have 2 routes to the destination. We have Fabric A and we have Fabric B. If Fabric A has a convergence event and FSPF is running, that's okay because I still have the route to B at the same time. So you would theoretically only have an outage in Fibre Channel if you have a double outage. Okay, if you have a failure simultaneously on A fabric and B fabric. But as long as you have multiple links, multiple nodes, and you're able to heal the network around the change, then you should be fine as long as the failure doesn't occur literally at the exact same moment. Okay, like if you're using one switch, both for A fabric and B fabric, like vSAN 101 and vSAN 102 on the same physical switch, then you would have a single point of failure. Okay, but otherwise you typically separate these into multiple different physical boxes so that it's less likely that you run into a double failure. Okay, but we'll see the nice thing about FSPF is that there's no config required. It runs automatically. Okay, you don't even need to turn it on. You just enable the port that goes between the switches. They automatically become FSPF adjacent and they start routing traffic. Okay, like any protocol, you can customize the options for it, like the timers, authentication, stuff like that, but normally you don't even need to do that. Okay, it's just plug and play from a Fibre channel service point of view.